Someone was asking whether these lithium cells for phones do actually contain charge protection, and I'd say they do, because when I was testing it, testing the solar power device, when I charged it on my bench charger, it would go up to about 4.2 volts, and then the current would drop off gradually, and then it would suddenly drop. Likewise, when discharging, it would run down to about 3 volts, just under 3 volts, and then it would just suddenly fade off quite quickly. So there is protection, but let's see what it looks like. The only way we can find this out is to see what's actually inside of one of these phone batteries. So it's got a metal shell inside. Is there a seam in that? Nope. So I'm guessing I have to prise this out the top then. Ooh. What's the worst could happen? I do have my flame containment dish handy. Should things go horribly wrong. I'll prise out the bottom of this as well, in fact. Oh, that's just stuck in the bottom. It's just trimmed. This is a completely enclosed metal container. Oh, that's quite good. That must be to catch the flames when things go horribly wrong. Ooh. So I'm guessing that the gold contacts here are on the same circuit board as the protection. And the cell, it's not sliding out as I was hoping it would. So this may go violent quite shortly. Oh. Oh! That's even more impressive. Rightio, I'm just going to cut that. Look at this. They've actually got a feed through on the metal container itself. It is completely enclosed in here. Is this completely hermetically sealed? I think that is somehow sealed right round. I can see what looks like a spot weld here, or is that a vent maybe? I don't actually see anywhere I can really get my snips in. This could go horribly wrong very shortly. Oh yes, this is now in the category of foolish things that I've done. Okay. That's now getting hot. That's not too good. Yeah, that's definitely getting hot. Anyway, while that's getting hot... Ooh. Yeah, this wasn't a good idea. Okay. Now this looks like one of the terminals is directly onto here, but the other one looks as though it's yeah, this was a terrible idea. Yeah, so one of the terminals inside in the cell is actually tacked right onto the back of this metal. And that's now separated. So maybe this other one won't short out. Oh, it's going. It's fizzing. Yeah, it's pretty hot. And it's getting hotter. Oh, that is getting very hot. That's about to melt down. Okay. While that's melting down and doing strange things, let's take a look at this. So this is the cap. Oh, I can smell that. I'm not seeing smoke. It's very hot. And it's dripping stuff. Excuse me while I wipe that off my fingers. We don't have any flames, which is quite good. Ish. Actually, I wanted flames. Oh, it's making that very distinctive sort of pear drop type smell that you get from cells when you've opened them. Yeah, so what's that actually shorted out onto? Okay, we'll leave that at the side here. While that is making quite a strong, hot and vapoury smell. So getting back onto the circuit board here. It seems to be housed in its own little plastic enclosure. And stuck on with double-sided tape. It really is well enclosed. I don't know if this has actually been physically moulded right in. It's certainly not liberating any secrets. Is that physically just potted right into there? I'm seeing a wee circuit board now. I would say that although that's probably still, it's cooling down again. I think that's it, controlled. I think it's probably shorted most of what energy was in it. It wasn't fully charged, but it was charged a modest amount, because I like to keep these things topped up a little bit. So I think it may have failed in a relatively safe manner. I mean, okay, that's slightly disappointing that it failed in a relatively safe manner. This is proving quite tricky to get into. It does look almost as if it's been moulded right into the plastic. I suppose that makes sense in the fact that they want to make it as small as possible. There's some surface mount components. There's some, actually maybe I've just pulled some surface mount components off as well while trying to get into this. Okay, there's a little 6-pin chip. Some of those other small components may have had 3 pins. They might have been the MOSFETs. Oh, that might have actually been another chip, another 6-pin chip that I've already just ripped off carelessly. So that might be the usual arrangement of the MOSFET package and the voltage sensing package. certainly the way it took the charge and cut off appropriately. Let's just get this little microscope in, and I'll see if I can read that number on that, because it's tiny. DW01. Yeah, that's one of those protection arrangements. So this will be basically the end of this with the gold contacts. The back of it has that protection circuitry on it, plus the connections for the cell itself, going on to one at each end. The cell, which seems to have tamed down a bit now. So let's have another wee go at that. Oh no, that's sparks and smoke and everything. It's not happy, is it? It's a fairly conventional the system whereby they roll the layers up. So it's the layers of foil with the electrolyte and the insulating the separator membranes, and then they are actually just sticking them through. So this is a hermetically sealed, well, it was a hermetically sealed enclosure. What voltage am I getting off that now? Has it really gone down that much? I don't think it will. I think it's kind of like melted itself clear. So there's one of the connections, and there's the other. Oh, it's still showing quite a good charge. So it is just kind of like burning itself clear, I think. And that's still almost fully charged at 3.9 volts, so it contains a lot of energy yet. So despite the fact you guys want me to blow this up, and you deeply do want me to blow this up, doing it indoors at my bench is probably an absolutely terrible idea. Not just going to like stop me going a wee bit further. Yeah, this is just something I should have done outdoors, isn't it? Yeah, you know what? I'm not going to push this too far, because this is just going to explode in flames at my bench, and that's not really necessarily what I want. But it's interesting to see the construction of it anyway. Yeah, this is something that will have to be shorted out later on outdoors, perhaps. Yep. Okay, sorry about that. A bit of an anticlimax, but at least we know what's inside now. Okay, well, still no explosion, but I have completely unwrapped this cell now, and it appears that most of what was going on there, the real sizzling and smoking, was coming from the fact this terminal here was being shorted against the metal casing, because the whole exterior here, the metal strip, the whole casing of that was basically one of the foil layers. So this thing is just basically wrapped round tightly. I don't think it's actually hermetically sealed as such, is it? Actually, it might actually have a sleeving round it. It does appear to have a sleeving round it. And a little rubber grommet here at the top, separating all the layers. So that's it really is just a sort of flat strip of the multiple layers of foil and the electrolyte soaked into the sort of membrane that's just wrapped round tightly to create a sort of cylinder but squashed very flat. So I'm thinking I may actually be able to solder onto that and at the very least discharge this in a controlled manner and get some juice out of it. I don't particularly fancy leaving it in my workshop overnight, just in case it finishes its job and bursts into flames. So yeah, it's quite interesting to see how that's made. Quite interesting indeed. Well, this is a new look. Kitchen towel and rubber gloves. That means something exciting is going to happen, like some sort of cheap porn flick. But in fact, we're going to be opening this lithium cell up now that I've discharged it completely, and we're going to be unravelling it. I mean, we might as well just destroy the thing completely. And so one of the most notable things, the outer metal casing, I thought it might be connected to negative, but it was actually connected to positive. Keep that in mind if you're using these cells, these lithium batteries out of phones, in a project. The only thing between the positive body of this and the your project, basically, if you've got it pressed against the circuit board, is the sticky label on the surface. So that's worth noting. So let's start unravelling this. This is like, as I say, it's like some cheap porn. I should be saying sexy things like, do you know what I like the most? Cake farts. And for anybody who doesn't get that reference, don't look it up on the internet, it's bad. It's very bad. Do not look up cake farts on the internet. Anyway, let's get this done. So this was kind of going a wee bit explosive when I was taking it to bits. So what have we got here? We've got the one layer of foil. Then we've got this plastic film. And then another. Actually, no, it's a... let's see. That must be the active layer, I'm guessing. Oh. This may still hiss and spit because it's still got a bit of charge in it. So let's pull this out and see what we're getting here. What sort of length it is as well. Oh, that's not necessarily good. So, there are multiple layers here. Right, okay, I'm just going to unravel this beforehand. It feels like, I'm not sure if this is aluminium it's on or some other alloy. Okay, that's us. So there's one electrode, which is this layer. Then there's that plastic film, and then there's the other electrode on the other side. And they're just basically rolled, oh that's very aromatic, into a sort of very tight, that is very fumy. It smells kind of, it doesn't smell unpleasant, probably is unpleasant. Now, I don't know if this is the normal colour of this or if it's because I exposed it to quite serious temperatures when I shorted it out a couple of times while I was trying to get it apart. But yeah, that is coated on both sides, so that, whatever foil that is. And I'm guessing this is permeated. This looks like a plastic, a sort of milky plastic ribbon. And I'm also guessing that when you have a meltdown, it's this that melts and it stops, then the two sides touch and you get a very high current flow. So I'm actually surprised how little there was in that. In terms of length, I was expecting it was going to be something bigger, but it kind of fits in the screen here. Hold on till I get a measuring tape and we'll just measure that. About 420mm, and the active bit of that will probably be 420mm-ish as well. Yes, just over 400mm. So yeah, there's not really, given the capacity of those things, given how much energy they hold, it's surprisingly simple inside. I mean, ultimately I'm guessing it's energy being stored in the surface in the form of a chemical transfer. I'm not 100% sure. I've never really looked into lithium polymer cells in that detail. But seeing inside it now, it's quite interesting. This is very rainbowy looking with sort of copper bits where it's gone round the ends. I don't know if the copperiness is maybe where the coating is, where it's not been making as tight a contact. It's maybe just, don't know, or maybe that's the stress of it going round the corners has actually broken some of the stuff off. I'm not 100% sure. But yes, it's interesting, very interesting. And yet they're so mass produced and so cheap, it's just surprising. And there's not, I think most of what's actually here is the aluminium electrode, if it is aluminium. In this case, it's got this insulating layer just pinched round it of what looks like a fairly standard Kapton tape just folded round the end. And that's bonded on, I think it's crimped through with, it is. To join this more rigid electrical strip on, and I struggled to solder onto that. I don't know if that's a steel or an aluminium material, but to join it on, they've basically put it over and then they've punctured it and folded it round to sort of crimp it, almost like staple it onto itself. And the other one here, it was just basically, it seems to almost be just like placed on and taped onto the surface. I don't know if they spot weld that in any way. I don't really see any way they could. I do see a wee hole there, so maybe that was kind of spot welded on. But then that would have been through the material. So maybe it is just laid on, literally just laid on the surface, and the fact it's pressed on quite tightly makes the connection. So that's quite interesting, yeah. So that was the complete teardown of the lithium cell. Oh, the chips that were inside, I checked up. One moment, I'm just going to grab that data, in fact. No, I've lost it. I've lost that data already. What was interesting though was the DW01 chip, which is the charge regulator that was built into the tiny little bit of plastic in the end. It's got the 2 voltage thresholds built in, but the lower voltage threshold, the one where it cuts off, I always thought that it had to be down about just under 3 volts, but it actually goes down quite low before it cuts off. I guess there must be a bit of leeway, and I have noticed that when you're discharging the cells, and it does cut off at that lower voltage, as soon as the current stops, the voltage just floats up a little bit to the sort of normal, you know, fully discharged level. So yeah, so that's inside lithium cells, the complete shred.